stuff, guys, for you is the following. We will have a PDUs and a UPS system in our project that we have, guys, right? We have a computer room, which I know you're doing lighting, Adam, now. Next week, you will be doing power. This computer room has racks of computers. These computers have to be backed up by batteries as well as the power. Okay, so I know this is busy, guys, but you did the riser math. When you did your riser, remember that taking a feeder from the switch gear, right? To feed something called UPS system. And from that UPS system, I think we have two UPSs, right? This time we had two UPSs. This example has one UPS and we're feeding two PDUs. A UPS, Karen, is called uninterruptible power supply. That's what the UPS stands for. Meaning, if you lose power, there is a backup battery. There is a backup battery coming in right here that will cover your load for 15 minutes. That 15 minutes is so important to shut down the system safely or start your generators. Who uses UPS systems? All guys, every high-profile manufacturer or vendors or what's not, they have a UPS system. When you go to Home Depot and you buy something at Home Depot and they slide you a credit card, this information has to be stored somewhere in a data center, in a computer. That computer is sitting somewhere in the country, in a bunker, literally, and that can handle tornado 5 or what's not, backed up by generators and backed up by batteries, so it maintains the business continuity for all these businesses that we have in the US and elsewhere. From Google, did you guys hear about the data centers that Google is building? Thousands and thousands, millions and millions of dollars. So every business, guys, have a data center. We at Dunwoody have a backup UPS that back up everything that you store on the network, backed up downstairs and powered by batteries. Did you guys hear me why the UPS is so important? We're going to go to Allianz right here, insurance company, like State Farm. We're going to tour their data center, and Adam is going to walk into the data center, look at these racks, basically racks full of computers, powered from both sides. They have two sources of power. Actually, they have three sources of power. They have one coming from the electrical utilities, coming right in here. They have one coming from the battery. They have a battery directly tied to them. And they also have right here, they have also generators. So the job of the UPS system, guys, if you lose power, your system will not shut down. Will continue to operate for 15 minutes typically. After 15 minutes, that's enough to start your generators, because generators need at least 10 seconds to start. They can't just come instantly. Can't drop the load instantly. You lose millions of dollars if you drop the load instantly. So that's what a data center is for very, very essential systems. Typically finance and security and what's not, all these big companies, Department of Commerce, Department of Defense and all this stuff, they have a UPS system. Okay, so let's start from this one. Adam, you have a high voltage panel coming here, the switch gear, right here, can you see that? You're taking a feeder to feed the UPS system, which is uninterruptible power supply, has a battery coming to it. What the UPS guys does is they take an AC, convert it to DC. They have converters. Take AC, right? Convert the AC to DC. We're taking the AC at 480, converting it to DC, typically 660 volt, around 600 volt DC. When they convert it to DC, all this is happening inside a big fat box. You guys will be walking around it when we go to Allianz, not next week, I think next week or the week after. So that big box, that's called UPS, convert the AC to DC, then bring the batteries. They have a bank of batteries. We're going to be touring a room like this, guys, with full of batteries. They bring a feeder, tie all these batteries. Batteries, guys, is like exactly like a battery. You take a 12 volt and 12 volt, put them in series. What do you get? 24 volt. So you keep adding 12 volts until you build up enough voltages to get you close to 600 volt. And then they tie him to the DC bus. And then they bring him, that's inside the switch here. Then they bring him into a DC-AC inverter. Then they invert them back into AC. Now we're going back into AC system. And there's a little distribution system right here with two circuit breakers, and bring them back into what they call it PDUs. PDUs is power distribution units. A fancy name for two things. Adam. A transformer and a panel in one box. Now, when we go to Allianz, you're going to be walking around these PDUs. You're going to see a big gray box sitting along the wall, and you can see them in our project to put the PDUs. Fancy name for two things carrying the PDU. A panel exactly like this one, and a transformer in one big fat fluffy box. Did you guys hear me what a PDU is? So then they bring the power at 480 to a transformer inside the same box with a panel. From here, they have two PDUs. They take one branch circuit from this one from the other one, and they feed it to a computer server. That's how your server is. So literally, they take a 20 amp receptacle from there, guys, 20 amp circuit breaker, and a 20 amp circuit breaker underground, underfloor, to a receptacle like this. So they will have two receptacles, one coming from one panel, one from the other panel, and my server, my computer has two cords. One cord will plug in this circuit, and the other cord will plug in the other circuit. So they have dual corded. They have computers, they have two cords on them, or servers. The whole idea is, as I slide my credit card and I spend $1,000 at Home Depot, they want to record it and make sure I'm not going to lose anything, and get the money from the credit card and from me. Finance, big deal. Every time you go to your Facebook, guys, and you load to your Facebook complaining about Chad or whatever, or your life, it's recorded into the data center, backed up by a UPS and PDU, guaranteed, all over the world. We made Guy here and Michelle Kuderks and Michelle made millions of dollars, guys, building them all over the country. For Google, for Facebook, Twitter, all these accounts that you think of, as well as the Department of Defense, the Department of Commerce, the U.S. government, the state government, Bloomington, where I live, every city has a data center that backs up their data. Cool? Everybody understand it? Data centers, racks, computers full, we need to back them up. We cannot tolerate interruption of power. Cannot. So that the batteries here will give you typically, when we go to audience, you'll see a room like this full of batteries. Like I said, it will give you 15 minutes. Within that 15 minutes, they have generators outside. They fire the generators automatically. They come up. They actually come up within less than a minute. But that 15 minutes give them just in case something happens. It allows them to kind of manually start these generators instead of automatically start the generators. Did you guys hear me why the UPS is so important? Okay. So now, and it has AC to DC converter, creates a lot of heat. That's why they have a dedicated cooling system to cool the UPS system. When you go to the data center of Allianz, you're going to see that they have crack units, computer cooling units, sitting, it's basically AC system, air conditioning, sitting in that room, cooling these computers. If you don't have them, and there's a situation where these fail, guys, literally, these servers that made out of non-metallic material, like my computer, they melt from the heat. These generate so much heat. Your laptop generates so much heat. That's why you have your fan there. Imagine having 1,000 computers in one room, crunching numbers, how much heat they generate. And these are bigger servers. A lot of them are 100 times more powerful than the laptop that I have in front of me, crunching numbers and storing them. Big deal. Okay, so I hope, and Guy will talk about it more. My job and yours, guys, is to size the system now. So here's what we need to do. First, I need to go size the UPS system. Second, I need to size the overconduction device on the primary side. Third, I need to size the feeder. Fourth, I need to go size my PDU that's coming from the UPS system. And fifth, the overconduction device for the PDU. And number 6 will be the feeder that's coming to the PDU. UPS and PDUs are a big deal, guys. The way, if you can see it, the UPS basically connect the DC to the AC and convert them, right? Then, after you convert them, it has to distribute this power. UPS does not distribute the power. The UPS just does the conversion. And then the power is distributed through these called in power distribution unit, PDUs. Cool? So here's a big box, taking the AC, convert it to DC, tying it to the batteries, and inverting it back to AC. Then 2 free circuit breakers and send them to PDUs. Also, the UPS could be in one room, guys, and the PDUs typically in a completely different room. 2 PDUs, and these PDUs are panels sitting against the wall and feeding all these racks of computers. Any comments, guys, about PDUs, UPSs? PDUs, UPSs. This is the key word here. So shall we go size these, how many things? 6 things for this system? Your job, guys, is to size the UPS and size all the associated feeders and overconduction device for it. So can you guys see that on the primary side is typically 480, secondary side is 208. There's a main circuit breaker inside the box. Can you guys see these main? and there are 20 amp circuit breakers here. It's a panel, and you bring a branch circuit to feed that server right here, the server, from both sides. And you guys, when we go to Allianz, we will open the raised, they call it raised floor, and you will stick your head atom there, and you will see the feeders coming to a receptacle and feeding and plugging into these servers and feeding up. Okay, I want to remind you that PDUs are 208 because there is a transformer inside them. The UPS is 480 because there is no transformer inside it. It takes 480 here, convert it to DC, and invert it back at 480. So you have 480 system, 480 DC, 660 volt, 480. Come to here up to this point, it's 480. Inside the PDUs, it converts it to 208. Now we're at 208 here, and we dump it at 208, 120, 208 across these servers. And some of them are fed, guys, 208. Some of them are fed directly from 2 hot. Some of them are 120. Okay, shall we go in size? I have 2 examples for you. Everybody understand the system now? Derek, does it make sense? Karen? And I spent some time on it because it's very, very important to understand why we have it. We still have, guys, we're going to go to Allianz. When you go there, they'll talk again about it. So hopefully that will stick in your mind. Okay, let's go ahead and size. Now, here's the formula that I would like to use, guys. Now, here's what's given. First of all, what's given? These, you have to get these from the engineers. I have a power, I'm going to change this power factor, guys, to 0.9. Can you get change that one? I know yours says, change this one to 90%. My distribution system, my servers have a 90% power factor. The power density, there's something called power density, Karen. It's 30 watt per hour, 30 watt per square foot, which is really very small compared to what they do right now, but this is the example. So these, based on these criteria, can you also change this one, guys? This one here, erase this one here. And right now here as losses. And add losses multiplied by losses factor. Okay, so I would like you guys to do that. Change them, update this information. One more time. Here's my computer room. Adam, I have a computer room. Can you guys see that? 20 feet by 20 feet. I have UPS, PDU, exactly like you guys have in our project. I have all these servers, racks, and we're feeding all these racks from PDU1 and PDU2. The density for this data center, the computer engineers that designed the data center, they told us they're going to put 30 watt per square foot. Every square foot is going to be loaded 30 watt. They are going right now to 200, 300 watt per square foot. The power factor for the system is 0.9, and we're going to fill this 20 by 20 with these computers, and we need to size the UPS for it. Here's the formula I'm going to use. Square foot, SF is the square foot, multiplied by the density, multiplied by the losses. There's losses, you can accommodate for the losses factor, divided by the power factor by 1,000. That will give you the kVA for the UPS. Let's go ahead and plug these numbers and see what we come up with. Okay, what's the square foot of this building? This building, I'm telling you guys, the square foot of this building is 20 feet by 20 feet. That's the square foot of the building. Multiplied by the density of this data center is 30 watt, multiplied by the loss factor. Can you guys put loss factor equal 10%? I have a loss factor 10%. I have a loss factor 10% I need to accommodate for. So I need to increase my system here by 1.1 because of the loss factor, right? 10% loss factor. I need to increase my system 10% to accommodate for the loss factor. Divide them by the power factor is 0.9. Divide by 1,000, of course, so it can convert everything to a kVA. Ladies and gentlemen, I don't have the answer for this because I changed them. I need somebody to give me the answer. 2 people, please. Because I changed a few things here. So 20 times 20 times 30 times 1.1 divided by 0.9. Yeah, but in order to accommodate for the loss factor, you need this amount plus 10% extra. See what I mean? This is 1.1, guys. Did you guys hear me? 1.1 is accommodate. The 1 is for the system. The 0.1 is index. So how much? I didn't hear it. 14.6? 67 second? Okay, so this will 14 equal 14.67 kVA. So I have a second. Yep, I got a second. Thank you. Then, Adam, you're going to take it to 1 floor, 14.67. In the 1-4, I guys made a copy for you. Please don't look at the copy that I made for you. What I did, I picked up sizes of UPSs from manufacturers. Sizes, can you guys see them? Oops. Can you see them? And that you should have it on that sheet that I give you. Adam, you have the sheet handy? Yep. If you guys look at right here, everybody can see that size right here. It says UPS. These I'm going to use it for UPS and PDUs as well. UPS in kVA. So what did we say the size? 14. What's the smallest I'm going to put? 40. Now, there might be a smaller size by the manufacturer. For the test and for everything else, I would like you guys to stick with these numbers. Just in real life, you're going to contact the manufacturer, say, here's the size what I want. What size UPS do you guys have? We have 25, for example, and use 25. Okay, so based on the data that we have, we're stuck with the 40 kVA. I have 40 kVA, right? Everybody understand where the 40 came to be? It might not be the accurate one in real life. You guys have to pull the data from manufacturer's UPS system. For the time being, for the test and everything else, use these information. Okay, disclaimer here, because there might be one that's 20. So you're going to use the 20. The only thing that changes is the sizes. Okay, good. Let's go. So we got the 40. Then, since it's 40, it's not. I have my calculation based on 42, so it's not going to change. Now I have the answers. So then I need kVA. Now then the size of my UPS is 40. Call the manufacturer of UPS. I think Collar Hammer now bought one that makes UPS system. Call them and say, I would like to buy a UPS, 40 kVA UPS. And they ship you that big fat fluffy 480, 40 kVA UPS. And with it, they will size batteries that comes on the side. Do you guys hear me? That's how they do it. Okay. So then you take now to size the overconduction device for the UPS. Now we sized, remember we came up with the size of the UPS. Here's the size of the UPS here. Now I want to go to number 2, which is overconduction device, right here, that big over here. Okay? I want to go size that baby. Okay, Adam, we need to size it. We need an amps. So you divide this one by 1.73 times 480. It's a 480 system. So that will get you a 48 amps. Okay? Then you go 1.25 multiplied by 1.25 continuous load 480, and that will get me a 60 amp. And you take your 60 amps to 240.6, and that will get you 60 amps. If it's not standard, you go up, and that's my 60 amp circuit breaker. So you take a 60 amp circuit breaker there, full feeders to the UPS. Done. Let's go to the feeder, shall we? So that's the UPS overconduction device. UPS feeder. Adam, it's identical. The same as the overconduction device. Same calculation, guys. You take 1.25, multiply it by the full load current, which is 48. We already did this one. End up with 60 amps. Take that 60 amps. Take your 60 amps. 60 amps. Take it to 315P16, 75-degree column, and that will get you 3 conductors. Number 6AWGTHN. Now, Derek, why 3 conductors? Typically, UPS guys at the UPS, we don't need a neutral. So what we do is we send 3 phases to this system. It's a 3-phase system only. Number 6. Remember to go to 75-degree column. Everything is 3-phase, rated for 75-degree lugs and what's not. Now, Karen, I found the actual size of the UPS. I put a circuit breaker 60 amp in the panel, the main panel, and I pulled 3 conductors, number 6, from that panel into the UPS. Now the primary side of the UPS is done. Now I'm going to go out of the UPS to the PDUs. Do you guys hear me? Out of the UPS to the PDUs now. I'm going to go size the PDUs. I'm done with the UPS. I'm going to take feeders from the UPS to size the PDUs. Okay, so let's go. Now we need to size the PDUs. For the PDUs, do me a favor. We're going to do the same calculation, guys. Change this one to loss factor, please. Loss factor here. Can you guys change this one to loss factor? And we're going to do the same identical calculation that we did. PDUs and UPS, same identical calculation, guys. So we're going to have number 4 here. So I'm going to use 20 times 20. You guys remember that 20. Multiply this one by, the density was 30. Multiply this one by 1.1. The loss factor of the PDUs, we're going to assume the same loss factor, guys. There's loss factor, there's transformers, right? You're going to have losses in them. We'll assume 10% loss factor. Can I add this one? Loss factor equal 10% loss factor. So here's where the 1.1, divide everything here by 1, the power factor. What's the power factor? Same power factor. 0.9, multiply this baby by what's the 1,000 to convert it. And Kieran, what did we come up with again? The same number should be 14.67 kVA. 14. And by the way, the size, Adam and Derek, my friend, they size the PDUs and the UPS in kVA, not in amps. They size them in kVA. When you want to buy a PDU, they will ask you, what's the kVA of this PDU? They don't say what the amp of this PDU. UPSs and PDUs are sizing kVA. Very, very important. So, okay, so then you're going to take this number that we just came up with, 14.6K, take it to the DeWalt, guys, and that will give me the same number, 40 kVA. Now, PDUs and UPSs are similar in standard sizes. In a real life, though, you're going to go to the manufacturer of the PDUs and ask them, here's what I would like to buy. What's your next standard? If they have a 20, instead of 40, what do you put? 20. For the test to standardize, guys, please use these numbers I gave you. The same numbers that from that DeWalt page, guys, is use them as PDU and UPS. Okay, then you can imagine the calculation will be very similar then, right? We got that one. Then if you go to the number 5, you need to take the same thing, the PDU 40 kVA divided by, on the primary side, 1.73 times 480, and that will give me 48 amps. Now, Adam, the PDU has a transformer. Can you guys see that there is a transformer right here? There is a transformer inside it. Unlike the UPS, there is a transformer for the most part. So when I size it, I'm going to size it like 450.3B transformer. When I size the overcam protection device, I'm going to use 2.5. Why 2.5? Because there is a transformer inside that panel. It has a transformer, maximum. Okay, so 2.5 times 480, and that will get me 120 amp. Then you take the 120 amp, you drop it down to 110 amp. So I'm going to go right here, which is in reality, it's going to be right here. Can you guys see that? Right here in that section of the UPS. The UPS will have a section, guys, for distribution section right here. In that distribution section, I'm going to put, typically, you have to tell the manufacturer, they put a circuit breaker for you 110. Now, if the manufacturer said, guys, no, we're going to make it 100, because they know their system, they can size them. We follow what they tell us. If they don't tell us this, what we believe that we need. Okay, so we got these. We got 110. So that's that one right here, 110. Then now we need the feeder. The feeder is piece of cake here. For the feeder, I need PDU, my feeder. You take the full load amp is 480. Now remember the feeder, this one right here. We need to size that one. Multiply this baby by 1.25 because continuous load, and that will give me. I'm going to do it right down here, so because I have room. So then you're going to have 1.25 times 4, 880. What do I have? 60 amps, right? And then, Karen, I'm going to take my 60 amps here, right? And from my 60 amps here, I'm going to take it to 3 to the 15 B16, and that will give me 3 conductors, number 6AWGTHHN. The same number that for the UPS, right? The same feeder that's coming from the UPS, the feeder that feeds the UPS is the same as the feeder that's coming out of the UPS, in this case. Cool. If you have 2 of them, they will be the same size because of redundancy. What they do, guys, they typically, if they need 1 UPS, they put 2, and they load them 50%. Why do they do that? What happens if this it craps on you, right? Well, what happens if this malfunction? Then they'll turn it off, and this will be fully loaded. Redundancy. It's all about redundancy. They want this system to be running at all times. That's what the goal is. Okay. So we got that one, guys. We got number 6, that's about it, right? Number 6 is about it in terms of. So these are all the sizes that we guys did. So that's my PDU. On the secondary side, so that's what we size. When you ask the PDU guys, what they typically do, they would have a panel attached to the PDU. For example, with the 40 here, they will have a panel. What's the full load current on the secondary of the PDU? If you guys take 40 divide by 1.73 divide by 208, so this panel will be, is that true? So 40, 1, 2, 3 divide by 1.73 equal divide by 208. So on the secondary side here, guys, this panel most likely will be a 125 amp panel with all these circuit breakers, 20 amp, 20 amp. So, but these will be sized by the manufacturer. So when you tell them, Matt, when you tell them I need a 40 kVA transformer, they give you a PDU, they give you this PDU and this panel with it. You know what I mean? The same size. So they will size it. Any comments, guys? Any questions? Let's go one more example and then we're done. Now, I'm going to size another example for PDUs, guys, and UPSs, and then we're done. The same pictures, everything is the same, everything is completely continue to be the same. But this time, I'm going to size it based on the following. I would like you guys to change this one to 0.9, please. You don't have this picture of it. I have 90% power factor. Density, instead of density, we're going to use the density here. If you guys change this one, the density, we're going to have 5 kW per rack. 5 kW per rack, and I have 24 racks. Okay? The same room, guys, we're going to have 24 racks, same room. One more time. I have a room, 20 by 20, and lately they start sizing by racks, guys. You can 2 ways you can size it, either by racks or by square foot. So for the racks, we did one for the square foot. We're going to do the second one for racks. So please write to yourself another formula. Instead of this, I'm going to say number of racks. That's the only thing. And instead of this one, multiply density or loss factor. Okay, so can you guys write the little formula that says number of racks multiplied by the density multiplied by the loss factor divided by a power factor. Instead of square foot, we go density. Now I don't have a calculation for this, so you're going to help me, right? You guys are going to help me for a little bit. So let's start. So the number of racks, I have 24 racks. Oh, by the way, this is, Karen, this is our project. This information is pulled directly from our project. So you guys are going to be, the size that you're going to come up with right now, all the numbers, you're going to be putting them in your project. So 24 racks multiplied by, the density is what? Per rack, 5 kW. Oh, by the way, because we have 5 kW, I'm going to get rid of the 1,000 here. Can you guys get rid of the 1,000? Okay, because I have, it's coming in 5 kW. Get rid of the 1,000. Everybody get that? K. Multiplied by the losses, 1.1. Okay. Divide by a power factor of 0.9 power factor. And I do not have the answer for this, so I need one of my best friends to give me the answer. 2 people, please. 15. 14.6K. Do I have a second? No, that's yeah, that's what I mean. That's right. 146 even. 0.7 kVA. Thank you. 146.7 kVA. Cool. Do me a favor. Take the 146.7 kVA. Take it to the wall. The sheet that I gave you guys. What's the next standard?
160.
160. I do have a second from that little sheet. 160 kVA. So my UPS is 160. Yeah.
If you're just using it as 5,000 down below, but you just leave it on there just in case, because if you don't get rid of the K, then you can't get rid of the 1,000.
Yeah. If you're using this formula typically.
Well, yeah, but wait, when it says 5 kW, that's 1,000. You still have to divide it by 1,000 because it's still 5,000.
No, you don't divide by 1,000.
Well, if you do 24 times 5 times 1.1 times 9.
Divide by 9.
Yeah, divide by 0.9.
Should come up with 146.7K.
Yeah, but you still have to, if it's 5, if you did it as 5,000, that's really like that.
Oh, if you did it as 5,000.
Yeah,
Yeah.
Yeah, so it should still be there.
All right. But as long as you know it's a K.
Yeah.
If you're given, if you're given 5,000 watt here,
The same for clear curves.
it's a K, guys.
Yeah.
Yeah, you.
Same for clear curves.
Gotcha. I hear you. But as long as you know the 1,000 is coming just to convert to a K. Okay, so we have 160. Let's go size for 160, shall we? So now my UPS will be 160, Adam. So let's go size. The first second thing, I have 160 kVA divided by 1.73 times 480. I don't have the answer, so I need you guys to help me. Any?
192.7.
192.7 approximate, right?
Yeah.
Is this a number? What did you say, Karen?
She said 192.45.
0.45. Maybe it's just approximation because of the 1.73. I bet you. Let's stick with that one, and then you're gonna go next with 1.25. Multiply this by 192.7, and what do you guys come up with? Please.
240.8.
240.9 amps. Second, something around this number. And then you're going to take the 240.9 next, and that will give me 250. Right? I have 250, right? Can somebody verify?
Yeah.
I have 250. So my overcome protection device on the primary side, Adam, is going to be 250 amp circuit breaker. 250. Okay, now the conductor size, the UPS conductor, the same calculation as we did it a second ago. The UPS feeder, we're going to repeat ourselves. 1.25 basically times 192.7 gets you 240.9 amps. We're going to take the 240.9 amps, take it to 3 10 to 14 P16, and that will get you a healthy I need help with that.
250.
Second, 3 conductors, number. Anybody have a second? Second, gentlemen, ladies, the size of the conductor, 250. 250, and everything is covered, right? 250, 250 kcm, THM. So that's the size that you guys are gonna have for your project. That's the actual size you're gonna have for your project. Cool? Any question, guys, about sizing the feeder and the overcome protection device? Everybody's good with that? All right, so let's go next. PDUs. For the PDUs, Adam, do me the same favor, gentlemen. For the PDUs, we're gonna change this formula here into loss factor, and I will change it from a square foot into what? Rack number of racks. Okay, so do me a favor. It was 24 racks multiplied by the density. Should I do the 5,000 now, just to play with that one? Here's the 5,000 watt times the loss is 1.1 divided by power factor 0.9 multiplied by 1,000. So my friends will be happy here. What did we come up with, guys, here, please?
146.7.
146.7 kVA. Same calculation that we guys did for the UPS. Same calculation. And then, Karen, you're going to take it 146.7 kVA. Take it to the 12-3 where I wrote them for you, and they will give you 160 kVA. Now, in real life, Karen, these sizes might be different. So you're going to go to the manufacturer. Typically, they are very close to each other. You choose the next standard. So you ask them for 146.7 PDU, and they'll tell you, hey, we make 150. You stick with 150. Am I making sense? You go to the next standard. For the ease of installation calculation, let's stick with these numbers that you guys have a standardization. 4, 5. Shall we move to 5? Or am I going too fast here? Okay, this is my 4. 5, we need the overcome protection device, guys, on the primary side. So same calculation, we did 160 kVA, 1.73 times 480. Give me the numbers. We did that one before. 192.7 amps. Now we need to use 2.5 here because it's a transformer. Yeah, 192.7. That's new calculation. What do you guys come up with?
481.8.
481.8. Do I have a second? Okay, 481.8 amps. Take it to 240.6, and you see that will get you down to. We don't have 450, do we? We have to go to 400. Do we have 450? Do we? I can't remember. I don't think. Do we? Yeah, we have 450. So we're going to go down to 450. 450, yeah. Now that's the maximum that you can use. Now, can you use 200, guys? Could you have used 200 or 250? Yes, you can. If the manufacturer come back and say, we recommend using 250 instead of 450. That's a maximum you can use. Doesn't mean you can use it. The maximum you are allowed to use it. Now you can use lower than that. Okay, the conductors. The conductor size, guys, is 192.7 amp. You multiply 1.25 times 192.7 amp. What do you guys come up with here? How much? 240.9 amps. And then you're going to take the 240.9 to, did we size? We sized this, didn't we? So what do you come up with?
250.
Yeah.
How many conductors? 3 conductors still. Number 250 kcm THHN. So that's the conductor coming to the PDU. That's this one here. That's 3 conductors. What did they say? 250 kcm. Now I would like you to do one more calculation, guys. We're done basically. The other calculation is I want to see what size panel most likely they will put with this. So how am I going to do that? Let's just say I'm going to point to this and have calculation right here. So can you do me a favor? Take the 160 divided by 1.73 times 208. 208. What do you guys come up with? Remember, there's a K. 160K divided by 1.728. 445 N. So most likely, this panel will have a 500 N. So what they do, remember, the PDU is a transformer and a panel. So what they do, guys, they put the transformer in one section. Right next to it, they have a panel that rated for 500 amp with 20 amp receptacle, 20 amp circuit breakers in it. I can't emphasize, guys, next week or the week after when we go to Allianz, you're going to be looking at these PDUs and UPSs. Now, we don't size anything for the 500 Karen because these are all in one box already. Can you guys see that circuit breaker here and that bus here? It's all manufactured big box. Or we just bring a feeder to it. But it's good to know the amps that you need here because that amps is going to be distributed. Typically what they do, guys, they have that box and they have multiple panels on both sides. Here's my PDU. If I'm the PDU, guys, on this side you'll have 225 amp panel, 225 amp panel, 225 amp panel. 3 panels fit from the same transformer. Okay, so finally, is this which homework is that? Is that homework number 16 or number 7 and 8? Okay, yep. Homework number 7 and 8. So here's what I would like you guys to do. I would like to change this one though. I would like to change one little thing here. For this one, homework number 7, I have 150 kVA demand, so you don't have to do the calculation. Like the second example that we did. You don't have to do the 180,000 receptacles. Do you guys hear me? This is already done for you. You're just going to take this number, find the transformer, and go. Okay, Karen, this is similar to the receptacle second example. This one here is a computer room 30 by 30, power density 100 watt. Change this one to, I need this one to be changed, guys, to 90% power factor. 90% power factor. And size UPS and power PDUs. Do we have a loss factor? We don't have a loss factor. So let's do a loss factor of equal 10%. Can you please add these one? Loss factor is 10%. So this is like the first example that we did about the PDU. Cool? We're done. Any comments, guys? Any questions? Comments, questions? I hope that will be helpful. Now, moving forward, guys, and sizing and what's not. Okay. Thank you.